Good afternoon, ladies and gentlemen. This is your video lesson for today. I am out of the building. So today what you're going to do is follow along in the notes like you normally would in class. I'm going to ask the sub to pause the video when necessary. So please follow along, take down the notes. The first thing we're going to do here is the warm-up. And what I would like you guys to do, if you haven't done it already, is to pause and do the warm-up. And we'll come back here in a second and discuss it. So go forth and prosper. All right, you should have had some time to finish that up. Let's talk about the first one. It says half the difference of 16 and a number is 4. All right, so as I'm looking at this, it says half the. We could also add in the word of. Half of the, and we know of means multiply. So I know I'm taking half of multiplication something. It doesn't tell me a number afterward. It gives me an operation, which means I'm going to have parentheses here. You see me having written. And I'm taking a difference first. That's what the parentheses do. It tells me to do something first. So what am I taking a difference of? 16 and a number. Remember, when we see difference, we know it's going to be subtraction, and whatever comes in order, first and second, has to appear exactly that way. You can have N, W, it doesn't matter what variable you have. So far it's half, 1/2 times, this looks like crap now because I'm writing over it, but you get the idea. Parentheses, difference of 16 and number, so that's our, and then the last part here is 4. We also know that means equals 4. Okay, next one. This we spent a lot of time last class talking about a problem like this. So number 2, Mr. Vesbach is going to build a rectangular patio. He wants to put a fence in it. He wants to fence it in, but only has 76 feet of fencing to use. The patio's length must be 4 feet less than twice the width, okay? I'm going to just underline that before we finish reading. Length must be 4 feet less than twice the width. What is the length and width of the patio? So a couple things that I noticed here. We don't know anything about the width. Nothing is mentioned about the width, only in relationship to the length. So for that reason, I'm going to make width just equal to W. You can make it equal to any variable, but you know, W makes more sense. And then width is related to the length, right? So we can write an expression for the length. Length must be, length equals, we'll call that L, okay? And L, the length, is going to be equal to 4 feet less than. Okay, when I read 4 less than, that means I'm doing something first and then taking 4 away. So what am I doing first? Taking twice the width. So we have 2W minus 4. All right, so now I get to my dimensions, and I can draw a picture from that. The picture looks like this. Get rid of the shade here. I have 2W minus 4 for the length, and then the width is just W and W. Okay, so let's go back to the problem. And what is my length and width supposed to add up to? Okay, we're talking perimeter here. It's supposed to add up to 76 feet. So that means if I took all of these sides and added them up, I should get 76 feet. So that's exactly what I'm going to do. So if I start on the left-hand side here, it's just W plus 2W minus 4 plus W plus 2W minus 4 equals 76. And from here, this is a problem that we should know how to solve from earlier in the year. If I combine all my like terms, all my W's here, I got W here, 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 and here, I have 6W. If I add up all my numerical parts, I have minus 8, and now that's equal to 76. And now I just solve this. I add 8 to both sides, plus 8 plus 8. I get 6W is equal to 84. Divide by 6, divide by 6. W is now equal to 14. So now I've actually found the width of my rectangular patio. In order to find the length, I have to substitute that in. So L, the length, is equal to 2 times that 14 minus 4. L is then equal to 28 minus 4. 28 minus 4 is 24. So I have a length, L is equal to 24 feet. W is equal to 14 feet. You might see a problem like that in our upcoming assessment, since we've covered things like that a lot. Okay, so what are we talking about today? Oh, by the way, your independent practice, hold on to that for next class. Don't turn that in today. That's your independent practice stuff. This is clipped in. All right, so this is what we're talking about. We're called solving for a variable. These equations we're going to talk about today are called literal equations. Literal equations are equations that don't necessarily have numbers in them, and you don't get a numerical answer. You don't get an x equals 2. You'll get something like x is equal to a plus b divided by c, and that's okay. If we knew what a and b and c were, then we can go ahead and find out a value for x. But since we don't know what they are, what we're essentially doing in these problems are doing what we would normally do to solve an equation, but we're not doing the computational part. Okay? So if we have that mindset about these, on the outset, it might look like saying to solve for x in this is very strange and very hard. But on the inside, what we're really doing is we're just setting up what we would normally do, but we're not doing any computation. So if we have that mindset, we might think it's a little bit easier. All right, so let's dive into some examples. We'll get back to that one. So this is a formula that's used to convert Celsius temperatures to Fahrenheit. Okay, so we get F is equal to 9/5 Celsius, Fahrenheit Celsius, plus 32. And if we convert all of these temperatures, and I can have you guys do this now. So go ahead and pause the video. What we're doing is saying, all right, every value of F is equal to 68. Okay, and I want to know what the Celsius temperature is. So we're going to take 68. And we're going to substitute that in here. And so we'll have an equation that looks like 68 is equal to 9/5 C plus 32. I want you to go ahead and compute these for this table. All right? So actually go ahead and plug in 68 for F. Plug in 212 for F, plug in 32 for F, and then calculate the table. So go ahead and pause the video and do that. All right, hopefully you've had some time to go ahead and work these out. I have an example here for the first one of the work that would be expected to see on an assessment or an independent practice. So I'm setting up the equation. 68 is equal to 5/9 C plus 32. I'm subtracting 32 from both sides in this step. Okay, that leaves me with the 36 equals 5/9 C. And then here you're seeing me multiply by the reciprocal, right? Multiplying by the reciprocal of 5/9. And then 5/9 times 36 gives me about 20. And so all of those could be calculated in the same fashion. We get 20 degrees, 100 degrees, and 0 degrees. So here's the thing. If you ever wanted to do this, it's a little annoying that this C value is right here and you have to continue to solve it, okay? It would be much easier if I asked the question, well, all right, I'm going to go ahead and give you a value for C, and say C is equal to 10, and I want you to go ahead and find the value of F. Because then all we're doing is regular simplifying of an expression, for the most part, right? And we're getting our answer for F, instead of solving an equation to get it. So the skill here is how do we make this equation a little bit more useful when we are trying to find a Celsius temperature. So we're going to rewrite the formula with C all by itself. So in the end, I want to have C equals some stuff, right? So I'm solving this equation for C. Well, what did we do in the past problems to get C all by itself? What we did was we started out by subtracting 32. Now, over here, it's going to feel a little bit uncomfortable because I can't take 32 away from a variable, right? And that's okay. Remember I said we're actually not doing the computational part. You can't do that. So all we're going to do is write down what we are supposed to do. And we'll say that F minus 32 is equal to now 9/5 C. And now we're getting a little closer, okay? And then after that, what did we do? What did we do in the last step, in the last problem, right? We ended up multiplying by this 5/9 on both sides. We'll end up doing the same thing because we have to get rid of this 9/5. So I'm going to multiply by 5/9, both sides, 5/9, not 5. Kind of looks bad over here. This also implies that I must distribute this 5/9, okay? So on this side, my 9/5, well, let's cancel out. Remember, 9/5 times 5/9 is 1. We get 1 C. C is all alone. Okay. So I'm going to rewrite this now and say C is now equal to, if I distribute this 5/9, well, instead of distributing it, what we can really just say is that I have C to start off as C is equal to 5/9 times F minus 32. Otherwise, it's going to look a little goofy here. And if I'm really multiplying here, I have this as a numerator of F minus 32 over 1. And if I multiply fraction times fraction, C is really equal to 5, and then parentheses F minus 32 in the numerator. And then the denominator is 9 times 1, so I have the whole thing over 9. Okay? So that would be our complete answer. So really now, if I asked you the question from before, all you'd have to do is plug in F in the equation, subtract 32, multiply by 5, divide by 9. And now if we do that for this value of 41, it's a little bit simpler. So C is equal to 5, and then if I substitute that 41 in, 41 minus 32 over 9. See how this becomes a much more easier problem to handle. Okay, 41 minus 32 is 9, so we get 5 times 9 over 9. And actually, if you take a look at this, the 9's cancel out. So we get C is equal to 5 degrees. Okay? So in my opinion, this was much more useful. And that's why we work with literal equations to manipulate equations to get them what we want them to be, the more manageable, and so forth. So let's practice some more. These are a little bit more generic. We want to solve the following equations for y. We're going to do that in both A and B. So here's what I like to do. I like to identify the variable I'm trying to solve for, and then understand if it was a normal equation, what would we do first? Hopefully your answer would be to subtract 2x from both sides. So then that would leave me with just the 4y on the left is equal to, and again, this is uncomfortable, right? How can I take 12 minus 2x? You can't. So don't, and just write down what you're supposed to do anyways. Okay? 4y is equal to 12 minus 2x. Y is still not by itself. I do have to divide by 4 to get rid of it. And I have to divide by 4 over here. So when I do that, I end up with just y is equal to, and literally without simplifying, this is my answer. Okay? But remember, I have two small problems here, and I'll identify that in a second. I have two small problems. I have 12 divided by 4, and I have this negative 2 divided by 4. That I can simplify. All right? So my actual answer is y is equal to, get back to my pen here. The actual answer is y is equal to 12 divided by 4 is really 3, and then this is a negative 2. 2 divided by 4 is 1/2, so we can say plus negative. I didn't mean to write equals there. 3 minus 1/2 x. Okay? Or we could have written like this. Y is equal to 3 minus x over 2. Those are both the same answers. Okay? Good deal. So this is a good answer, but you lose half points for not simplifying like that. All right? What I would like you to do is pause the video and go ahead and try part B on your own. A little bit more difficult in terms of fraction, but give it a shot. All right, what I've done here is gotten the first step knocked out, and I wanted to show you guys what to do with the 2/3 because that seems to be an issue that sometimes we talk about and or want to deal with. So all I've done so far is subtracted this 8x from both sides, and as you see, all I'm left with is the original negative 2/3 y, solving for y, and now I have to get rid of this negative 2/3. So I have to divide by 2/3 or negative 2/3, but I never divide fractions. I multiply by the reciprocal. So that looks like being multiplied by negative 3 over 2. Remember, this gives me 6 over 6. 6 over 6 is 1, so I get 1y, which is what I'm looking for. And then I also have to do it to the other side, so times negative 3 over 2. So over here, this gives me 1y, which is what I need. And on the other side, I have to distribute this number. Okay? So what I'm left with is negative 45 over 2. 15 times 3 is 45. Remember, this is really 1. 2 times 1 is 1. Minus, this is actually 12x. Okay? So that would be our final answer. All right? Hopefully we're gaining some traction on this. I want you guys to actually go ahead and work on number 4 by yourself. Pause the video and try that one. Solve it for x this time. All right, in this problem, at this point, you should have easily recognized, like, yeah, I got to subtract, or add rather, y to both sides. And then you should have recognized, well, clearly I can't add m plus y, so you just write down what you're supposed to do. I wanted to talk specifically about what to do with this one. So what's happening to x? I'm multiplying by 3. I undo that by dividing both sides by 3. And literally, what I just said, divide both sides by 3, completely is what has to happen. I have to divide everything on this side by 3, and so it looks like that. So my answer does become x is equal to both m divided by 3 this way, but also y divided by 3. Okay? So let me get rid of that and write our final answer here. Y is equal to m plus y over 3. Okay? This means the same exact thing as saying y is equal to m over 3 plus y over 3. Okay? These two answers are identical, except for this one is a simplified version of that. However, this one might be a little bit easier to understand what actually is happening. So you have to have this knowledge of what's going on in order to understand what's really happening here. So, last one here, solving for y. This one, for solving for y, I'm identifying that variable. I have to undo the addition before the multiplication, so I'm going to subtract 4x from both sides. Then I'll have 5y is equal to, and then again, subtraction, right, has to happen in the same order, so I have 40 originally, and I'm taking 4x away from that. Can't flip that order around or it's wrong. And then the same thing here. I have to divide both sides by y, bring it up a little bit, and everything gets divided by y. So initially, what this means, well, hold on a second here. Not divide by y. Whoops. Divide by 5. My bad. Divide everything by 5, because we're solving for y. Ugh. All right. So I'm dividing everything by 5. And again, I really have 2 division problems here. So then y is equal to 40 divided by 5 is 8 minus, and then this one I can't really do anything with, right? So 4 divided by 5, I can't simplify that as a fraction, so I can just leave it in one of 2 ways. 4x over 5, or I can leave that as 4/5 x. That means the same thing. All right? So this would be your final answer. These 2 issues here are interchangeable. All right. So moving on here. This one's kind of a doozy. It says solve the following formula is for finding the surface area of a cylinder. We will use this next year in geometry. It says rewrite the formula to solve for h. Holy cow, there's a whole lot of stuff there. What am I going to do? Well, the first thing I'm going to do is recognize what's happening to h. All right? And so what I want to say is that it's first being multiplied by these 3 things at the same time. All right? Then, after I'm multiplying, I am adding that entire quantity. If I knew what r was, then I can multiply by pi, or I can square it, multiply by pi, multiply by 2, and this would be just like a number like 10 or whatever, okay? So we got to think of this as one quantity being added. And so what I'm going to do is I'm going to just rewrite that whole thing. S is equal to 2 pi r squared plus 2 pi r h. H is the variable we're trying to solve for, right? So I'm going to undo that stuff in the reverse order in which I just said. So the last thing I talked about was adding this, so that's what I'm going to subtract. I'm going to subtract the entire quantity, not just one at a time, because, well, for a lot of reasons, but that's the correct thing to do. Minus the entire quantity. So it's minus 2 pi r squared. And so now this also feels a little uncomfortable. What was there first? What did I originally had? I originally had s. Let me bring this up. I originally had s, not equals, but now minus the 2 pi r squared. That whole quantity is now gone from that original part, and now I have that being equal to the 2 pi r h. So now we're a lot closer to what we had before. All right, let's take a look at what we have. I still have to solve for h, and what's happening to h? I'm multiplying by all those things. And so I'm going to undo that multiplication with division. So I'm going to divide by the entire 2 pi r. Now when we look at it over here, I have two division problems. I have this one, and then I have this one, right? And so in simplifying, there's nothing I can do with this one over here. It is still s divided by 2 pi r. S over 2 pi r. If I look at this one, though, this one here, I have 2 divided by 2, which is, and again, I'm subtracting, right? I have 2 divided by 2, which cancels out. I have pi divided by pi, which cancels out. And r squared is really equal to r times r, right? So I have r times r divided by r. Well, one of those is gone. So all I have left out of this is 1r. And now that is equal to my height. Okay? So let's just go back to that last step here one more time and kind of briefly reanalyze that. What I'm doing is I'm dividing by the 2 pi r, and I'm realizing I have two division problems that are separated by the subtraction symbol here. This one that I circled, you cannot simplify it out, right? So you can't simplify it, so I just wrote it down. We are separating it by subtraction. Okay, and then I just did a bunch of canceling on the last one. 2 divided by 2 canceled out. Pi divided by pi canceled out. So I ended up having only, since the r times r over r cancels out one of those r's, I have only the r that's equal to h. All right. Average Joe's Gym has recently expanded and has been gaining members. Currently, they have 122 members and are gaining 6 new members each week. We want to write an equation for the number of members, that represents M, at Average Joe's Gym after W weeks. Okay, so we have this idea that they're expanding, they're getting new members, they're gaining members, right? And we want to know how many members at Average Joe's Gym after W weeks. So that would mean that our members are equal to, they already have 122, so that's our starting point, right? And what are we doing? We're gaining members, so we're adding to them. How often? 6 per week. So we said W is week, so 6W. Now we want to take this equation. Let's say Average Joe wanted to say, well, if I solve this for W, then I can answer questions about member-week relationship, right? How many weeks will it take me to get this amount of members, or how many members will I need to have, at this certain amount of time? Things like that. So it's useful to go ahead and solve this for W. So instead of doing it down here, I'm going to do it right up here. So again, ask the question: what's happening to W? I'm multiplying by 6 and I'm adding 122. I'm going to reverse and undo that. So I'm going to subtract 122 first. 122. Again, order has to stay the same here. So it has to be M minus 122. I cannot compute that, and I end up with that being equal to 6W. Lastly, I have to undo the division. Undo the multiplication with division. So I'm dividing both sides by 6. Okay? And again, I get 2 division problems here. So I'm going to continue on over here. That W is what's left. So W is now equal to M divided by 6 cannot be simplified, so I will leave that there. We are separating by subtraction, because we subtracted the 122. And then 122 over 6 can be simplified to 61 over 3. Okay? So this would be your final answer. All right? So yeah, if Average Joe's knew how many weeks, or knew the amount of members that they wanted to have for a goal, say, I want to know when I'm going to have 1,000 members, okay? And they can plug the number 1,000 in here for M, and this formula would give them an estimate on how many weeks it would take them to get there, and they can do some planning based on that. All right, Mr. Kirsten has $55 in the bank and is adding $20 per week. Let B be his balance after W weeks. Write an equation for B in terms of W. All right, so what do we have? Let B be the balance in his bank account. Okay, so B is going to be equal to the balance in his bank account, and what's happening? He has $55 in the bank already. That's his starting point. And he's adding plus, and how often is he adding, and what is he adding? He's adding $20 to the bank, and he's adding it weekly. Okay, so that's our original equation. Now I'm asking the question, so we're not just saying solve it for something. I'm asking you a question that might change your mind about what this formula should be. It says, when will he have $175 in the bank? Use your equation to solve for this. Well, $175 in the bank is this value, right? And I want to know how many weeks that's going to be. So what do I have to do? I have to substitute that 175 in here. 175, start over. 175 is equal to 55 plus 20W. And now I have to solve that for W. Solving for W, minus 55 from both sides. I get 120 is equal to 20W, divided by 20, divided by 20. And extend page, W is now equal to 120 divided by 20 is 6 weeks. So at 6 weeks, he will have reached his goal. All right, so today, what are we talking about? We talked about this idea of literal equations, where if I have an equation that has no real numbers in it, but it's a lot of variables, I can still solve for a variable to make it useful. We saw that it was useful when we solved this equation for C in order to make it a little bit easier to convert Celsius or Fahrenheit to Celsius. And so remember that all we're doing is doing what we would normally do to solve any equation. You already know how to solve equations, so do what you would normally do, except for we cannot sometimes calculate what we end up with, and that's okay. And that's, in my opinion, sometimes it makes these easier. We just have to get over that hump of the fact that we're not going to get W equals something. Okay, we're not going to get W equals 4. So your independent practice tonight is on page 58 to 59. You'll find that in your online textbook, and you're going to do problems 1 through 25, only the odds. I hope you have a great day. Yeah, Monday, rock it.